Welcome to EduMath Hub. Welcome back. So today we'll be treating IGCSE Mathematics. So the topic is exponents. So we're treating surds later. So for today we're treating exponents. So for the content, we're talking about exponents and index notation. We're talking about the exponential or index laws. Then we ended up with zero negative index. So let's just get straight up into the class. So when you talk about exponents, exponent has to do with powers, powers, and exponents help us to represent large numbers in simple ways. Take for example, if you have a number like 64, for example, a number like 64, so you have 64. You can write this 64 in another way. That will be 2 times 2 times 2 times 2. Right now you have 2 times 2 4, 4 times 2 8, 8 times 2 16. Then you have 16 times 2 32, then times another 2, that will give you 64. So in exponential form, just count how many 2's are here. You have 1 2 3 4 5 6. So 64 is 2 raised to the power 6. So this exponential form is equivalent to the original number. So we can write 64 as 2 raised to the power 6. So the exponents help us to write very large numbers quickly. So we can write 64 as 2 raised to the power 6. We can also write 32 as 2 raised to the power 5. That is 2 times 2 4, 4 times 2 8, 8 times 2 16, 16 times 2, that will give you 32. So 32 is equivalent to 2 raised to the power 5. So the 5 at the top here is the power. So you can call it the power, you can also call it the index, or you can call it the exponent. While 2 at the bottom is the base. So the base raises the power. You can see the base raises the power. So when you have a raised to the power 5, a is the base, a is the base, 5 is the power, or you can also call it the index. So that's the use of exponents. It helps us to represent large numbers in a very simple way. You can also represent small numbers in exponential form. Coming back to that, so let's just move on. So 2 is the base, 5 is the power, a is the base, 2 is the power. The one at the top is the power, the one at the bottom part is the base. So the base raises the power. That's another way of looking at it. So let's move on to the next part, which is writing numbers in index form. So you have this question right here, which is the next part. You have to write 72 in index form. So it's pretty straightforward. So you break 72 down using repeated division. So you have 2 in 72, that will give you 36, 2 in 36, that will give you 18, 2 in 18, that will give you 9, 3 in 9, that will give you 3, 3 in 3, that will give you 1. So that means all these numbers here, if you multiply everything, you should have 72. So that will be 72 is equals to 2 times 2 times 2. This whole term is from this part here, 2 times 2 times 2. You have 2 times 2 times 2. Then 3 times 3, 3 times 3. So the number of 2's here is 3. So you have 2 raised to the power 3. That means 2 is appearing 3 times. Then the number of 3's here is 2. That means 3 is appearing 2 times. So you have 3 raised to the power 2. So at the end of the day, 72 is equals to 2 raised to the power 3 times 3 raised to the power 3. 2 raised to the power 3 is 8, and 3 raised to the power 2 is 9. So 8 times 9 is 72. That's another way of looking at it. If you want to try it for another number, let's assume you want to try it for a number like let's say a number like 125. So you do repeated division. So 5 in 125, that will give you 25. 5 in 25, that will give you 5. 5 and 5 will give you 1. So if you represent that out, that will give you 125 is equals to, you have 5 appearing 3 times here, so you have 5 times 5 times 5. So that will give you 5 raised to power 3. 5 raised to power 3 because there are 3 5s here. Okay, that's 5 in 3 places. So 125 is the same thing as 5 raised to power 3. Then let us try it for one number, another number. Let's try 36. So if you try it for 36, you do repeated division for 36. That will give you 36. So divided by 2, you get 18. Divided by 2, you get 9. Divided by 3, you get 3. Divided by another 3, you get 1. So 36 is the same thing as, you have 2, 2, 3, 3. 2 times 2 times 3 times 3. So you have 2 appearing 2 times, that will be 2 to the power 2, times 3 appearing 2 times, that will be 3 to the power 3. Sorry, 3 to the power 2. So this number is equivalent to 36. This is 4. 2 times 2 is 4. And 3 times 3 is 9. That's 3 to the power 2 is 9. So you have 4 times 9. This is 36. So 36 is equivalent to 2 to the power 2 times 3 to the power 2. So that's a way of breaking down a number to the index form. You can also reverse the process. They might give you the number in the index form, and you have to get the original number. So it's pretty straightforward. So here you have 2 to the power 2 times 3 to the power 3 times 5. Now when you see a number like 5, a number on its own, just standing on its own, like 5, 10, it means that the power at the top is 1, okay, and an imaginary 1 is there. If you see something like 4x y squared, it means 4 is to the power 1, x is to the power 1, then y is to the power 2. Okay, so that's the meaning. So when you see a number like just standing on its own like that, that's the power of 1, an imaginary power of 1. Okay, so we'll move on to the next part. So you break this number to 2 to the power 2. 2 to the power 2 is 4. That's 2 times 2 will give you 4. Then 3 to the power 3. That's 3 times 3 times 3. This value right here is 3 times 3 times 3. That's 27. Okay, 5 to the power 1 is 5. At the end of the day, you multiply these guys here, multiply these three numbers. That will give you 4 times 27 times 5. You multiply that, you get 540. So 2 to the power 2 times 3 to the power 3 times 5 is equivalent to 540. By the time if you try to do long division for 540, just the way we did it in the previous section here, you try it for 540, you will get 2 to the power 2 times 3 to the power 3 times 5, which is the same thing. Okay, so now on to the next part. You also have negative bases. There's sometimes that the powers or even the base might be negative. Okay, just like in this case here. In this case here, the power is positive, but the base is negative. The base is negative. The base is negative. Base is negative, but the power is positive. But it's pretty straightforward. Just make sure you look at the nature of the power. So anytime you have the power as an odd number, your final answer will be negative. Anytime you have the power as an even number, your final answer will be positive. You don't need to memorize it, but it's pretty straightforward. Let me just explain it like this. From here, you see minus 1 raised to the power 1 will give you minus 1. Minus 1 squared, it means minus 1 times minus 1. Minus times minus will give you plus. Then 1 times 1 will give you 1. Now, when you see a number like 1, when you see a number just on its own, 1, 5, or whatever, the sign, and there's an imaginary plus in front of it. So plus 1 and 1, they are the same. And in this case, you have minus 1 raised to the power 3. So you have minus 1, minus 1, minus 1. These two here will give you plus. Minus times minus is plus. Then you have plus times minus here. At the end of the day, you have minus 1. So the power here is odd. So the final answer is negative. But here the power is even. The final answer is positive. So let me just quickly do a short example for you so you can get it better. So now look at this here. You have minus 2 raised to the power 3, and you have minus 3 raised to the power 4. So in this case here, since the power here is odd, the final answer will be negative something. Negative. Here the power is even. You have an even power here. Final answer should have plus. Now 2 is appearing 3 times. That means you have 2 times 2 times 2. So this one will give you 8. 2 times 2, 2 times 2 times 2. Okay, so 2 times 2 is 4. 4 times 2 is 8. So this final answer here is 8. So you have minus 8. Minus because the power is odd. Then in this case, you have 3 appearing 4 times or in 4 places. So you have 3 times 3 times 3 times 3. So this 2 is 9. 3 times 3 is 9. Okay. Then you have another 3 times 3 here, which is also 9. So you have 9 times 9, which is 81. So this answer will give you plus 81. Now it is positive because the power here is even. So you have even power. The final answer will be positive. That's if you have a negative base. Now this principle will work irrespective of the number inside the brackets. For example, if you have minus p raised to the power 3, okay, it just means minus p times minus p times minus p. Okay, this 2 is plus and this one is negative. So at the end of the day, you have minus p raised to the power 3. So just know that for even power you have a positive answer, and for odd power you have a negative answer. So let's move right back to initial topic. So don't forget, the negative base is raised on odd power, the answer will be negative, and if you have a negative base raised on even power, the answer will be positive. So move to the next part, which is the exponential or index laws. Now in exponential law or in indices, when you see multiplication, it just means you should add the powers. Okay, this law here is the law of addition of powers. This one is the law of addition of powers. Okay, law of addition of powers. This is the law of subtraction of powers. So in indices, multiplication means plus and division means minus. So as far as you have the same base, the rule will apply. Let's check out the bases. So you have a and a and a. The power here is m, power here is n. So you have a. The base is the same. So you just pick one of the bases. Then m, n. What is in the middle? You have times in the middle. So you have times in the middle. So that means you should add the powers. So that will be a raised to the power m plus n. In this case, the base is also the same, but what you have in the middle is division sign, and in indices division is minus. Okay, so just subtract the powers. That will be m minus n. Okay, m minus n. Make sure the bases are the same. It only works when you have the same base. For example, this principle will not work if you have something like this. If you have a raised to the power 3 divided by b raised to the power 3, it will work, but it will only work if you have the same base. You can see the same base. Let's solve this one out. This is the common base here. That common base is a, so let's write that out, a. Then the power is 3 and 2. Then since you have division in the middle, it means minus. So let's do 3 minus 2. That will give you 1. So this answer is the same as a. Okay, so now let's move on to the next part. And the next law is the product law. This is the power multiplication of products. Okay, you have a raised to the power m multiplied by n. So you have a raised to the power m times n. This is power. This is power. That means two powers can multiply each other. Okay, you can form a product of two powers. So at the end of the day, you have a raised to the power m times n. This is also equivalent to bringing this n into the bracket. So a raised to the power m raised to the power n is the same thing as a raised to the power n raised to the power m. You can see that the powers have been interchanged. Here you have m inside the brackets, here you have it outside. So it's the same thing as having n outside and n inside here. So we'll be looking at examples very soon. Let us take the next part of the law. You have a raised to the power b raised to the power n. So here you have the power outside. Yeah, the power here is 1, imaginary 1. You also have imaginary 1 here. You can easily explain or prove this by saying this a is equal to a raised to the power 1 and b same thing as b raised to the power 1. Now everything is raised to n. So from this initial law, these powers can multiply each other. This is a power here. This power can multiply n. 1 times n will give you a raised to the power n. Then b raised to the power 1. 1 is also here. 1 times n will give you b raised to the power n. So they are the same thing. They are equivalent to each other. Okay. Now this is for products. It also applies for division. This n, the power here will just split itself for each of the terms. It doesn't work for plus or minus. Okay, it only works for multiplication and division. So don't make the mistake to try something like this maybe in the examination hall. So don't make the mistake to write something like this. It will be wrong. Like when you have a raised to the power m, then you have like you have a plus b, then you have n here. It is not equal to a raised to the power n, b raised to the power n. Okay, it won't work because there's a plus in the middle. It only works when you have a multiplication sign or when a and b are being multiplied. Okay, that's when it will work out. So don't make that mistake. It doesn't work too for subtraction. So we'll move on to the next aspect, which is examples based on the laws that we just looked at. So if you look at these simple examples here, you have 2 raised to the power 3 times 2 raised to the power 2. You simplify that, you can see that the bases are the same, 2, 2. Then the powers 3, 2. So just pick one of the 2's, the same base, pick it out. Then you have 3 and 2, 3 and 2. What's in the middle? Times. So that means you are doing plus, because in indices, multiplication stands for plus. So you have add the powers. That will be 3 plus 2. That will give you 2. 3 plus 2, that's 5. And if you break that down, 2 to the power 5 means 2 to the power 5 is 2 times 2 times 2 times 2 times 2. That will be 32. Okay, so this final answer here is equals to 32. Now move on to the next one. The same base, you have the same base, so just pick one of the bases. Just pick one. You have x, so you have x, because the bases are the same. Then the powers, just add the powers. You have 4 plus 5. So 4 plus 5 will give you 9. So that's the answer to that. Now in this next case here, you have the product law. So you have 2 to the power 3 in brackets, 2 to the power 3 in brackets multiplied by 2. So the powers can multiply each other. This is a power, this is another power. The exponents can multiply each other. So these two can be multiplied. So you have 2 raised to the power 3 times 2. 3 times 2 is 6. So if I answer, I give you 2 raised to the power 6. You can actually solve it another way. you have 2 raised to the power 3 raised to 2. Okay, so now to solve it another way, it means just write your 2 raised to the power 3 in 2 places. So that will be 2 raised to the power 3 times 2 raised to the power 3. Then you apply the addition law. The bases are the same. You have the same base, so you just pick one. Then the power is 3 plus 3. Add it together. You're adding it because you have a multiplication in the middle. So 3 plus 3, I'll give you 2 raised to the power 6, which is the same as what we had before. So the next part here, you have 3a squared. Okay, so that'll give you 3a. So you have 3a times 3a. You have to write it twice. So the same thing. This one has an imaginary one. This one imaginary one. So the same thing as writing. You want to use the product law. You also multiply it 3 times 3, 9. If you want to be straightforward about it, you can just say 3 times 3, 9. Okay, and a times a squared. That will give you 9a squared. But if you want to try it within the with indices, this 3 here is 3 to the power 1, 3 to the power 1, and you have the same base. So that's 3 to the power 1 plus 1. Then multiplied by, you also have a. The power here is 1. Power here is 1. So that will be 1 plus 1. At the end of the day, this will be 3 to the power 2, and this will be a to the power 2. 3 to the power 2 is 9, and this will be a squared. So it's the same answer that you're going to get. So let's move to the next aspect. So you have to simplify this. Pretty straightforward. You just have 2x. This is your 3 here. This 3. This 3 can be multiplied, okay, with the imaginary powers here. You have 1 here. You also have 1 here. The power of this y2 is also 1. So you have 1, 1, 1. So if you just simplify that, you can also have this part. This 3 is affecting everything in the brackets. Okay, it applies to everything in the bracket. So you have 2x. So you have 2x. Everything is to the power 3 divided by y is to the power 3. Okay, because this 3 using the product law. Okay, so 2 in 3 places. Okay, this 2, the power here is 1. Imaginary 1 is here. So you have 1 times 3. Power multiplied by another power. So that will be 2 raised to the power 1 times 3 is equals to, the power here is also 1 multiplied by 3. Multiplied by 3, that will be x raised to the power 1 times 3. Then divided by this y, the power here is 1. Y raised to the power 1 times 3. Simplifying it further, you have 1 times 3, that will give you 3. So you have 2 raised to the power 3, x raised to the power 3, then divided by y, 1 times 3. So if you just want to add it further, 2 raised to the power 3 is 8. That's 2 times 2 times 2. So you can just write 8x3 divided by y3. So that will be the final answer to that. Now let's close it up with some tricky examples. Now to solve this, you have 3a raised to the power 3, 3a raised to the power 3, then b raised to the power 4. This 4 applies to everything in the brackets. It applies to 3, it applies to a raised to the power 3, it applies to b. Imaginary 1 is here, imaginary 1 is here. So bring that out. You have 3a raised to 3 to the power 1, a raised to the power 3, b raised to the power 1. Everything is to the power 4. These powers can multiply this power here. This 1, 3, 1 can multiply 4, because that's the product law. Don't forget, the product law states that a to the power m n is the same thing as this m can multiply this n, m times n. So this will give you 1 times 4, that will give you 4. A 3 times 4, 3 times 4, that will give you 12. Then b, 1 times 4, that will give you 4. Finalize that. 3 to the power 4 is 3 times 3 times 3 times 3. That will give you 81. Then you have a raised to the power 12, b raised to the power 4. Okay, so that's that. Now for the other section, the other parts, you have this guy here. You have x squared over 2y is to the power 3. So the same thing here. Use the product law. This 3 is affecting, or it applies to everything inside the brackets, both the numerator and denominator. So you have x raised to the power 2 raised to the power 3 divided by 2y raised to the power 3. So 2 times 3, that will give you x raised to the power 6 divided by, imaginary 1 is here, don't forget that. So 1 times 3, that will give you 2 raised to the power 3 y. You also have imaginary 1 here. 1 times 3, that will give you y raised to the power 3. End of the day, you have, that will give you x raised to the power 6 divided by 2 raised to the power 3 is 8. Then y raised to the power 3. So we'll move to the zero or index law. So the zero law is just pretty straightforward. Zero law states that any number raised to the power 0 is equal to 1, okay? But it's a particular number that doesn't apply to that rule. So the number is 0. So when you raise 0 to the power of 0, the answer is actually undefined, okay? It's undefined, okay? But any other number apart from 0, like y raised to the power 0, 30 raised to the power 0, 2 raised to the power 0, any other number apart from 0, if you raise it up, you get 1. It can easily be explained by using the equivalent law. Take for example, we know that 2 raised to the power 3 divided by 2 raised to the power 3 will give you 2, because this is division. 2 raised to the power 3 divided by 2 raised to the power 3, that will give you 2 raised to the power 3. Division is minus, that will be 2 raised to the power 0. And actually, if you break this thing down, 2 raised to the power 3 is 8 divided by 2 raised to the power 3 is also 8. 8 divided by 8 is 1. So using the equivalent law, these two guys are actually equivalent. So 2 raised to the power 0 is equal to 1, and it applies to any other number. So any other number apart from 0 that is raised to the power of 0 will give you unity or 1. So that's about the zero law. Now we also have the negative index law. Negative index law, it works with the reciprocal law. You have a raised to the power minus n. You have a base raised to the power negative number. What you do is to remove this negative sign here. All you have to do is find the reciprocal of the original number. So you have 1 over a, then just put in the same power there, but don't include the negative sign. So that means this term here, this number here, and this one, that they're actually reciprocals. Okay, they are reciprocals. Okay, so let me explain it further like this. You have 2 raised to the power minus 3. You can also write it another way. You just write in your 1 first. 1 divided by, write this same thing, but don't include the negative sign. That will be 2 raised to the power 3. Okay, so you have actually flipped it using the negative index law. If you try it for another number, you have 8 raised to the power minus 2. To remove this negative sign, just write 1 first over write the same thing but don't include the negative sign. That will give you 8 raised to the power 2. From here, 2 raised to the power 3 is 8. Also write 1 over 8 here. And from here, 8 raised to the power 2 is 64. Then you can write 1 over 64 in this case. So that's how you use the negative index law. Let's try it one more time. So you can also work for variables apart from numbers. So a raised to the power minus m is the same thing as write 1 first over, write the same thing but don't include the negative sign. That will give you a raised to the power m. It also works if this base here is in ratio form, something like this. You have c, you have c, you have c divided by d, and you raise it to a negative power like minus m. Now to remove this negative sign, you just write 1 first, then you write the same thing here over c over d, then raise it to the power m. Okay, and this expression is the same thing as d all over c raised to the power m. So you just flip the terms, you flip the numerator and denominator, flip it upside down, and you have your normal expression. And lastly, a over b raised to the power minus 2 is the same thing as b over a. Okay, just flip this upside down. That will be b over a, then write in your 2. Don't include the negative sign anymore, because flipping this will remove the negative sign, just like we did in this other case here. Just like we did here, if you flip 8 to the power minus 2, when I wrote 1 over, this 8 is 8 over 1, but since I'm flipping it, that will be 1 over 8. Then you have the 2 without the negative sign anymore. So if you have c over d, you flip it, that will be d over c, then raised to the power m. Don't include the negative sign anymore. So that's how you use the negative index law. You can see it from here. A over b raised to the power minus n is the same thing as b over a. So b over a, then raised to the power n. Okay, so mere finding the reciprocal of this removes the negative sign. So you have b over a raised to the power n. So let's take some examples from here. You have to simplify the following. So you have 7 raised to the power n. 7 raised to the power 0, 7 raised to the power 0. Don't forget the 0 index law. Any number raised to the power 0 is 1. So this answer is pretty straightforward. Is equals to 1. Okay, this answer is equals to 1. Any number raised to the power 0 is 1, except 0. Now, in this other case here, you have 3 raised to the power minus 2. So to flip it, you just write 1 first, divided by, you write the same thing, but don't include the negative sign. That will be 3 raised to the power 2. Then this will be equivalent to 1 over, now 3 raised to the power 2 is 9. That's 3 times 3, 9. So that will give you 9 as your answer. So 3 raised to the power minus 2 is equals to 1 over 9. Now, in this next case, you have 5 over 3 raised to the power minus 2. If you try that out, just flip this, flip it. You have 3 over 5. Then don't include the negative sign anymore, just put in your 2. Now, using in the product law, this 2 applies to 3 and 5. So it's equivalent to 3 raised to the power 2 divided by 5 raised to the power 2. 3 raised to the power 2 is 9. 5 raised to the power 2 is 25. So that will give you your final answer. Then you have some more examples right here. This is half raised to the power 0. Half raised to the power 0. Don't forget, any number raised to the power 0 is 1. So when you have half raised to the power 0, you should know that the final answer should be 1. So this final answer is 1. Okay. This will give you 1 as your answer. This is 1 as your answer, because any number is to power 0 is 1, irrespective of the number inside the brackets. That should give you 1. Now the second aspect, you have 1 whole number 1 over 2 raised to the power minus 3. Just convert this to proper fraction. So you have 2 times 1, that's 2, plus 1, 3. So I take it into improper fraction, that will give you 3 over 2. 2 times 1, 2, plus 1, that's 3 over 2. Then we are raising it, this is being raised to minus 3. So use the index law, negative index law. So you flip this, flip it up, that will give you 2 over 3. I've flipped it, you can see 2 went up, 3 came down. Now don't put in the negative sign, just put in the power. Now this is 2 raised to the power 3. 2 raised to the power 3 divided by 3 raised to the power 3. So that will give you 2 raised to the power 3 is 8. 3 raised to the power 3, 27. So that's the final answer. To add the initial step, you can add this like 2 raised to the power 3 over 3 raised to the power 3. So the 3 here applies to everything in the brackets. So 2 raised to the power 3 over 3 raised to the power 3, that will give you 8 over 27. Then in this case, the minus 1 here only applies to PQ, doesn't apply to 3 because 3 is not in the bracket. So that will just give you 3 times, then let's flip this. By the time you flip this, that will be 1 over PQ. Then we are raising it to power 1. Power 1. So we have 3 times 1, that will give you 3 divided by PQ is to the power 1, that will give you PQ. So this whole thing is equivalent to 3 over PQ. Okay, now let me just quickly explain something about negative power of 1. You can use it to simplify your answers. Take for example, after solving a question and you have something like this. You have something like maybe 4 over c, or you have 4 over c squared, or you have 3 over p. Now to flip this, it's the same thing as 4c minus 1. The power here is 1, imaginary 1 is here, so that will be 4c minus 1. I'm flipping this, this is actually 1 over c. I'm flipping it to become c, so it becomes 4c minus 1. In this case, it becomes 4c minus 2. You understand? So you are flipping it. This one becomes 3p minus 1 because the power here is 1. Now, when you have 1 over 10 raised to the power 2, it becomes 10 raised to the power minus 2. That's how you flip it back. Then lastly, you have 5 over x squared y3. You flip that, you have 5. This one is 2, so it becomes x minus 2. Then this one is 3, it becomes y minus 3. So you can use this to simplify your answers and to make it look cooler. So we've come to the end of IGCSE mathematics exponents. So please, if you enjoy the class, like, share and subscribe. Okay, thank you for watching. Please don't forget to subscribe to the channel, it keeps us going. Thank you and remain blessed. Peace out.